Namaskaram everyone. Welcome back to the 34th episode of our Master Unreal series. And in this episode, I'm going to show you how you can mirror the animation and how you can position the character correctly based on the door's position that we created in the last episode. So if you haven't watched the previous episode, I highly recommend you check that because in that episode, we created the first iteration of how you can interact with the door. So if you haven't watched it, please do because it is connected with that previous episode. And now, without wasting any time, let's get started. All right, so we are in our editor now. In the last episode, I showed you how you can try to open the door with the current animation from the backside. Now, in this episode, we are going to implement the front side. So for this, I have to mirror this animation. So basically, whatever he is doing with his right, he should do it with the left. So basically, what we are going to do is something called as mirroring. That means mirror the animation that you are playing. So for this, we are going to tell animation blueprint that we want to mirror the animation poses that are currently playing. So only when you are opening the door from the front, we will mirror the animation which was originally created for the right side. Okay. So in the blueprints BLIs, you can create another blueprint interface and call it BLI anim states. Open it up, and in this you can create one function that is set animation tag. Now the reason I created this interface is because we are going to have more functions, but primarily this function will allow you to communicate any external data to the animation blueprint, because the animation blueprint is working in a separate thread and your game is working in the main thread. So to communicate the data between these two threads, we are going to create this interface. We were using Tag Manager, but I also want to show you another way of sharing data between the animation blueprint and the main game thread in which your entire game logic is playing. So let's go to our characters, mannequins, animations, ABP base. In the event graph, you remember we binded a tag listener, and whenever you used to run, the tag was getting published and you were receiving the updates, and then you were updating the running state. So now we are going to implement another way where you can take any tag for that matter and you can handle the states, keeping your approach thread safe. If you are following the series, you remember we kept this function thread safe. So if we don't keep it thread safe, then there is no point of implementing a communication. The whole idea is to keep the communication thread safe. So for this, I'm going to open my base blueprint. Under class settings, I'm going to implement this interface BLI underscore anim state. As soon as you do that, you can compile and you will find a function under the interfaces. So we are going to delete it and go to our BLI anim states. And here I'm going to add a return node so that it becomes a function. And for now, let's remove everything, just a simple return node. And this function is a thread safe function. Now you can compile, go to ABP base. Now double click and you will get your function. So we will use this function to update whether we want to mirror or not. So I will create a variable should mirror and I'll use small b in start. I'll bring this here. Now, since we are having this function, we will remove this event listener that we binded for keeping track of running state. So for this purpose, in the set animation tag, we are going to use a macros to determine the tag. And in the determine tag, we will create one output. So the first tag that we want to keep track is mirror, and it should be execution pin. Another tag is the running. So you can use this function for updating any variable by providing it a tag. In the input, I will ask for the tag. Okay, and we need the execution pin. And you can write it fully execute and it will disappear. Okay, and now you can use a sequence node. So first is to check whether you want to mirror or not. So I'll get this tag and I will use something called as matches tag. So if it is a running tag that has been added or removed, then we would pass it to running. And if it's a mirror, so for mirror, we had to create a gameplay tag. I would go in my edit project settings. I'll search for gameplay tags, manage gameplay tags, and I'll create a new gameplay tag abp.mirror. select this and press enter. Okay. So this means tags that are part of animation blueprints, nothing else. So now you can use again matches tag and search for ABP mirror and pass it here and make sure exact match is set to true. Now how we are going to use it? In the set animation tag, you can get this determine tag, and in the set animation tag we need the input. So here in the input I'll ask for the tag and go for gameplay tag, compile, go back, and there you have it. So if it's a mirror, then we will switch the mirror variable. If it's running, then we will switch for running variable. So call this here. So whether you want to set it to false or true, you will tell whether this tag has been added or removed. So back to anim state, and I'll create another variable and I'll call it b is added. That means is added, and I'll change it to boolean. Compile, go back, and now you have this variable. Now you can fetch this. So if the tag is added, that means you have to mirror. If it's a running tag that has been added, then I have to switch is running to true. If it is false, then the respective variable will become false automatically. So that is how you can communicate using tag, and you can tweak the variables of animation blueprint without casting. Once this is done, I will compile. Now we know whether we should mirror or run. And now how do we mirror? So in the animations folder, you can create something called as mirror table and select the SK mannequin, or if you are using some other skeleton, go for that. And I'll just name it mirror data table. I'll open it up, and this will just create a map of the left side bones to the right side bones. You can see this. So the center bones, spines, and neck is same, but if you check the left arm or left lower arm, left hand, it is mirrored to the right arm. So any movement in the left will be converted or will be mirrored by the right, and the right one would be mirrored by the left. So you can save, and once you are done, in the anim graph, you can access it from here as well. Once the pose that we have to play is finalized, which is at this particular place or before this, we are going to call mirror with mirror data table. And here we are going to use our variable that we created, whether we should mirror or not. By default, it would be set to false, and I can compile. And before we edit it, let's test. So right now it is false. I'll set it to true. And if I compile and play, and if you're following me in parallel, you will be able to see the movement is different. If I press E, you can see I'm using my left side this time. So this is how you can mirror the animations. I'll set it to false because we only want to mirror if you are standing in front of the door. If there is some different animation, you can use this interface to communicate whether you want to mirror or not. So set it to false and compile. Go back to single door. And now we need to determine whether you are standing in front or you are standing at back. So I want you to go back to third person map, and now let's understand how you are going to determine whether we should mirror or not, or if I say in more simple terms, whether you are standing at front or at the back. See, this is the door, single door. You can see there is no rotation applied. It is placed in its default position. So what we call as direction vector or the forward vector, which you can also see here, this is our character and this is the facing direction. So you can see this arrow. So similarly, this door is in its default position in terms of location and rotation. And the forward vector is in this direction, or I must highlight here, this y-axis. So this is the facing direction. So if I bring my character here and if I rotate it by 90 degrees, so this, and press W and select the door, this is the forward vector or the facing direction of the door. And this is my facing direction. So if this is the situation, then we say you are at the front. But if we take the character back and rotate it by 180 degrees, now the forward vector of this particular door is still in this direction, but the character's forward vector is also in this direction. Now that is a different thing if your door is slightly tilted like this or that, but the idea is the direction vector is in the same direction instead of the opposite direction that we had like this. So we have to use this direction vector to determine whether you are standing at front or you are standing at back. So how do we do this is by first we subtract the location of this door and your character, and then we take the perpendicular line that is the x-axis, or also called as right vector, because this is the facing direction and this is what is your right vector. Okay, this is the positive, this is the negative half. So we will get this right vector and the facing direct, and we'll create a dot product that will give us the value. So if the dot product comes out positive, then you are facing front. If it is negative, then you are facing at back. Now this is more connected with trigonometry and mathematics. So if you want to go in the mathematical explanation, I suggest you check out the dot product, how it is done, and the logic that we are going to code, you can understand from that. So I'll create a function and I'll say should mirror. Okay, so first we want to know the character, so I'll just name it actor and I'll get this actor. So always keep your classes at a higher level based on your demands and requirements. Since we do not want to interact with any kind of character movement component variables, we do not make it character. Instead, we go to a top level that is called actor, because we just care about the location and rotation. And the actor is the best class to use because it covers wide range of entities. If you want to include in your game, this is flexible and extendable. If you do character, then this door cannot be interacted by anything other than character. So right now we don't have such case, but still I like to keep the possibility. So we will get the actor location. If you want to understand the hierarchy system of Unreal, I suggest you check out the episode 2 and 3. I have explained in great detail how it works out. So this will give you the character's location, and we want to get the door actor location. So I'll just get the actor location, target is self, that means the door, and I'll subtract it. Once the locations are subtracted, we will perform a dot product, and the dot product with the right vector, or I can say perpendicular one. So get right actor, connect it, and the right vector of the door, not the character. Once this is done, it will give you a float value. Now it can be negative or it can be positive. So I'll perform a return node. So I'll go greater than equal to 0. So if it is greater than equal to 0, that means you are standing in front. So I'll say result. That means you should mirror if it is greater than 0, because you are standing at front and our animation is designed for the back. So we will send true, and if it is less than 0, then it will be false. You can check this. You can create another pin and you can call this ShouldMirror, and the actor would be this character, and you can print the string. So just a correction, when I said door, that means this scene component. I'll rename it to door. Okay, and now you can get this door and you can get its right vector, and you can delete this and connect this one. Okay, we are good. So we only care about this scene component, which is containing our door handle, instead of this entire thing. Just to be more specific, and just a correction in an event graph, this should be connected with the in string. The results, compile and play. Now if you go at the back, you will see false. That means you do not have to mirror, but if I stand in front, press E, you can see it says true. All right. So our direction prediction is working fine. So I can remove this for now. And now we know when to mirror or not. So before we execute the logic, we will get this should mirror and the character. Okay. And now we need to also create the position for the front side. So I'll go back to my viewport. If you cannot find it, just go in window, viewport, and it will bring it up. Now you can open the skeletal mesh. This is the back position. Search for visible, make it true. And now this is something manual, but still I'll do this. Okay. And now you cannot do that mirroring here in this animation asset. So you have to do this manually by going back and forth in the level. So for now, I'll just copy the location and I'll duplicate this backside position and I will call it front side position. I'll paste it. Rotation is pretty straightforward. We can just set it to 180 degrees in negative, of course. Okay. Now if you compile, and now this will tell us whether we should mirror or not, and we'll create another function, position actor, and this is where you will position the character. So instead of doing in the event graph, we will just cut this entire thing. We'll go in the position actor, we will plug it here, and then we are going to ask whether it is standing at front or back. B is at front, and we'll change it to boolean. I'll use the select get is at front. I'll get this backside position and front side position. So if it is at front, you get the front side. If it's at back, it gets the backside position. And then you can connect this here instead of connecting it like this. Now, once this is done, you will get the dedicated position and you will move the character. Now see, there is another catch. Let's say even if you are opening it from the back, this particular door can be placed like this as well. Now this is the back. Now your door is rotated. You can see it is rotated by minus 90 degrees. So in this case, you have to rotate the character as well based on this direction. Now if you try 90 degrees, it will not work. So first, let's pull this character back. And in the single door, let's make this one invisible. Event graph, you can call this position actor. Connected. Result will go here. Compile, play, and if you go in the back, press E, you can see it is still rotating as if the door is facing that direction. So if your door is placed in some different direction, which is obviously possible because you can plug this door anywhere and that building can be placed in this direction or in this or in this. So for this, we have to take care of the character's rotation accordingly. So I'll go in the position actor, and the rotation is taken care of by the yaw, which we have set to 90 by default. So for this, we will get the forward vector because the forward vectors tell you in which direction the door is facing. So based on this, I'll delete this and get the forward vector from the door, and I'll create the rotation from X. Y from X is because since Y is the facing direction of our door, we will create the rotation based on X. So if you have some other door or your own mesh where your direction is X, then you can make rot from Y. But in our case, it is Y that is the facing direction. So we will create the rotation from X. Now I don't care about X and Y because I just care about how much rotation to give in Z. So I'll get the Z value and I will subtract, and I'll call select float. And again, I'll check get is at front. So if you are standing at front, I'll rotate you clockwise. Otherwise, I'll rotate you anti-clockwise. Or maybe I'm saying opposite, but that's the idea. And let me actually do it. So if I set it to 0 and 0, compile. Let's try opening it from the back first. Press E. Now you can see it is facing in this direction. I have to rotate it by 90 degrees. But in what direction? In left. Since we are opening it from back, I will subtract minus 90, or basically I'll add 90 degrees minus minus plus. Compile, play. If I go in the back, press E. Now you can see it is facing in correct direction. If I'm at the other side, I would like to subtract 90. Here I'm adding 90 because it is negative. So negative negative becomes positive. Okay. And now if I hit compile, now this takes care of your positioning of the character based on the door. Now you have positioned the actor correctly. Now we have to do this same for set controller rotation. So I'll just cut this entire logic and place it in position actor like this. So I'll make a rotator this time, and the X goes here, Y goes here, Z goes here, and this time we break these pins, we combine, plug it here, and we plug it here. Compile, play, go to the back, press E. Now you can see it is facing exactly in your character's direction. Okay, so you have taken care of the controller's rotation as well. Now you can play the montage. And now we need to communicate that we want to mirror the animation if we are standing at the front. So once the actor is positioned, we would like to notify. So we'll get the character and its animation instance. And I would like to access set animation tag, which is our interface function, and I'll connect it here. And the tag is ABP mirror, and it has to be added or not will be decided by the result here. So I'll connect it here. Okay, once this is done, you can compile and play. Press E. You can see it is playing the left side animation. But if you now move the character, you can see it is acting weird because you didn't turn off the mirroring once the animation is over. So this is very, very, very important. So once the interaction is over, either by interruption or by completion, we also reset the mirroring animation. So we will get the character and we will access the anim instance and we'll set animation tag ABP mirror to false. That means it is removed. But we have to do this before the interaction and allow this set to true. Why before is because if you set it afterwards, then as soon as this becomes true, then another player can interact. So this character will be referencing to that character. And we wanted to turn off the mirroring for the previous character that was interacting. So this should happen before. So this is also an error. We should do this before. So I'll connect this here. I'll get it here, break this pin, connect this, connect this. So first you turn off the mirroring, then you reset the controller rotation, and then you allow the interaction. And play, press E, you are able to interact in the left, you are back to normal, press E, you are in the right, you are able to perform the back animation as well. Now you can try any other position if you want. Press E, rotate it like this, 180 degrees, play, press E. You see, now you are opening from front using the left and you are playing from right. In case you find the position weird, you can always tweak the front and the backside position where your character will be placed. Okay. Alright, so that's it for this episode. I hope you enjoyed it, and do let me know in the comment sections if you have any doubts or queries or hurdles. And if you want one-to-one help, please do join our Discord community for that. You can find all the animations, assets, and the starter project files that you need for this series available for free completely. And in the next episode, I'll show you how you can create the open door animation where your character pulls the door and it gets open and then it shuts back. So that is what we will cover in the next episode. So stay tuned, subscribe to the channel, like the video, share it with your friends. And if you have any feedback, feel free to post on Discord. Until then, take care and I'll see you in the next episode. Bye.